Okay, in this module we want to talk about adding radical expressions that do not have like radicands. So we have to relate this back to what we've learned. So if we go back to polynomial world, and if I ask you to add x plus y, we all know there's nothing we can do with that. X and y are not alike. We can't add them together and make one term. So we would have to write our expression x plus y. We all learned there's no way to change a letter into a different letter. But then if you think back to when we were working with rational expressions, fractions, if I wanted you to add 1/6 plus 1/8, right now those fractions are not alike because they do not have the same denominator. But wait a minute, we learned we can make the same denominator by getting the LCD. And the LCD was 24. And once we make the denominators alike, then we could put the fractions together. So in rational world, we could make the fractions become alike and add them. Well, the same thing is going to be true in radical world. If our radicands are not alike, maybe there's a way we can simplify them to get them to be alike so we can add our expressions. So let's look at our PowerPoint and our example. We have square root of 45 plus 3 square roots 20. So I see the operation add, and the first thing I notice is my square roots are not alike. My radicands are 45 and 20. They're not alike. So no, you cannot add. They're not alike. So what we have to do is we follow order of operations. We're supposed to be working inside the symbol anyway. Let's see if we can simplify, reduce these radicals. So if we have the square root of 45, what's the biggest perfect square in 45? Right, it's 9. So we would write 45 as 9 times 5. With the radicand 20, what's the biggest perfect square in 20? That's right, it's 4. So we write 20 as 4 times 5. Now let's simplify. If 45 is 9 times 5, we know the square root of 9 is 3, so a 3 would come out. 5 is not a perfect square, and 5 is prime. We can't do anything with it, so we're going to have to leave it inside the radical symbol. And that's why the square root of 45 can be simplified, reduced to 3 square roots of 5. Now we take the square root of 20, which is 4 times 5. We know the square root of 4 is 2, so a 2 comes out. Again, the other number 5 is prime. It's in lowest terms, and it's not a perfect square. It stays inside. So now we have the square root of 20 being 2 square roots of 5. But wait a minute. There was a 3 in front of the square root of 20. That 3 was connected by multiplication. So now we have 3 times 2, which is 6 square roots 5. So now look at your expression. It's 3 square roots of 5 plus 6 square roots of 5. What do you notice about your radicands? Oh, wow, they're alike. Now we can add. 3 square roots of 5 plus 6 square roots of 5 is 9 square roots of 5. So the moral of the story is real simple. Just like in fraction world, if the denominators were not the same, we got a common denominator so we could add and subtract. In radical world, if your radicands are not the same, your job is to reduce them first and then see if they are the same so you can perform addition and subtraction. All right, let's try a couple examples at the whiteboard.